Because if I ever want to refer you back to this, because it is one of the harder things, I can say, go watch this again. The little topic of this, ladies and gentlemen, is percent of change of dimensions. Okay, percent of change and dimensions. And the problem with most people have with this is it isn't necessarily logical or intuitive, which means it doesn't make sense because of what you're thinking. Okay? In other words, this, if you started, let me just, right off to the side here, let's say I draw a line and it is 10 inches long. And I said, draw another line that is 50% longer than that. Oh, if I said make another line that is 50% longer than that, how much longer would that other line be?
5 inches.
No, that is 5 inches would not be long. 50% longer.
15
inches. Okay, that is 50% longer. Why? Because you take 50% of this, which is 5, and you make it that much longer. Okay? Just let's get that thought process in your head first. Okay? For example, all right, Maddie's struggling with this, but let's say you go to McDonald's. Maddie, you ever go to McDonald's? Okay, what's your favorite food? How much? What would you guess? Give me a round number that's about the price of a 10-piece nugget. $5? $4? Let's say $4. Okay. Maddie goes to McDonald's. She gets her 4-piece nugget and it is, or a 10-piece nugget and it is $4. Maddie, if the price, because of this whole Ukraine thing, if the price was 50% more next week, how much would your nuggets cost next week? Started $4 this week, 50% more next week. $6 next week, because 50% of $4 is $2, it's half. And it's that much more next week. Okay. If you don't get that, this will come up here. Okay. Here is what this is about. The problem in percent of changes dimensions is that it doesn't always make sense, and I'll tell you why. Okay, so here's example 1. One square is 50% larger than the other. Okay, one square is 50% larger than the other. Now, point number 1. Why is the guy got the cube here? I don't know. Is this a real Rubik's cube?
Can you solve it like you did that one time in 6th grade?
I don't think it's. I don't. Ooh, it's got some nice motion to it.
Oh no.
You solved the chair.
No, this always confuses me when it gets to this part because it doesn't always go right. Wait, can you do this?
He's done it before.
Why
You
can't you
started
do
it
it
last year,
consistently? Wait, did you just say algorithm?
No.
No.
You got this, Sean. We'll take him and watch you. You believe.
I don't think it's gonna work.
Every time I find an algorithm, like
Wait a
I
minute.
got it discusses it all.
Wasted way too much time on this. So this is what doesn't make sense. Okay. First of all, this said that one square is 50% larger than another. The first thing you said, does it give you the dimensions of this square? No. And that's a good thing because it doesn't matter what the dimensions are. Okay? To answer the question they're asking, it doesn't matter. That means to do the problem, you get to pick what dimensions you want to use. Now, most people will go, okay, I want to pick 1 because 1's an easy number. But I'm going to say, no, you don't want to do that because taking 50% of 1, then you start having to work with fractions because half of 1 is 0.5 or 1/2. So you don't want to pick Well, 2 would be a good thing.
Two.
2, well, yeah, 0 is probably not gonna get you anywhere, because you're still in heaven. 10 is probably your best bet as a number, but just for fun, I'm gonna pick 20. Because half of 20 is really easy to, 50% of 20 is 10. So, write this down, we're gonna do this. This is a 20 by 20, it doesn't matter whether you call it inches or units or whatever. So if 1 square is 20 by 20, here's the chicken McNugget thing. If the new square is 50% larger, 50% larger, what is my new square's dimension gonna be? 30, right? Because 50% of 20 is 10, and it's that much larger, 50% larger. It's not 50% of, if it's 50% of it would be 10, but it's 50% larger. So let's label our new square as 30 and 30. Okay. Now, answering the questions. Here's where we have to do a little thinking here. The perimeter of the larger square is what percent of the perimeter of the smaller square? Well, first of all, let's not worry about the answer to that until we find the perimeter of the square. Perimeter of the small square, 20 plus 20 plus 20 plus 20. Let's not say 60, let's go 80. 20 plus 20. 4 20s is 80, right? Did you say 80? Now, I want you to stop just for a minute. Perimeter of the small square. Stop for just a minute. We made this square 50% larger. So without looking at the dimensions here, one would say, well, the perimeter of the big square should just be 50% larger than this, right? What's 50? David, 50% larger than 80 is 120, because half of 80 is 40, 40 plus 80. Let's look and see. The perimeter of the big square is 30 plus 30 plus 30 plus 30 is 120. Okay, that makes sense. That's the way it should be. Sam, are you with me? That just makes a ton of sense. However, here's where it doesn't make sense. Okay, by the way, the answer to this is, let's do this out. The perimeter of the larger square is what percent the perimeter of the smaller square? By the way, if percents ever throw you off, then change the word percent and say fraction, and then change the fraction to percent. So if I change this, instead of saying the perimeter is what percent, I said what fraction. The larger square is what fraction of the perimeter of the small square. Well, what's the large one? 120, right? What fraction of that is this then over the small square? Boom, boom. What do you get if you reduce that? Somebody?
2/3.
No.
3 twos.
3 twos. 3 twos, David, is what percent? 1.5, 150%. This is 1.5, which is 150%, which makes sense, right? Because I made this one 50% bigger. So it's 100 plus 50, it's 150. Okay, now, here's where all the wheels fall off. I've been working my whole life for this moment right now, because this is the big one. Looking at the area of the big square. Okay, one would think that the area would also be 150%. However, let's do the area. The area of the little square is, what's 20 times 20?
400.
400. What's the area of the big one? 900. So I'll write that over here in case you're wondering. Area of the small is 400. Area of the big is 900. I am looking for the same thing. What percent is the big one of the small one, or what fraction of the big over the small? Reduce that down. 9 over 4 as a decimal is, how many times 4 going to 9?
It's 44.
2.25, right? What percent is 2.25? 225%. It is not 150, but it's 225%. Now, why is that? Why was the perimeter only 150%, but the area was 225%? pick this up tomorrow, but here's the reason. No, Jackson, sit down.
Thank you.
See, what you have to remember in this is I made this side 50% bigger and I made this side 50% bigger. So when I do area, because I multiply, perimeter was just adding, so I don't do any multiplying. But when I multiplied it by 50% bigger twice because both of these dimensions were doubled or 50% bigger. So when you get it, this ends up being 50% double. I'll talk tomorrow on that.